Welcome to episode 25 of the Philosopher Science podcast, the podcast about free, Libre, and open source software for science. Today, David and I are interviewing Kurt Kremitzki about FreeCAD, a free and open source general purpose parametric 3D computer-aided design modeler. Hi, Kurt. Thank you for being with us today. Could you please introduce yourself?
Yeah, so as you said, my name's Kurt Kremitzki. During the day, I work at a company called Enthought, which is, I guess broadly speaking, is sort of a scientific computing consulting company. And we're sort of centered around the scientific Python ecosystem. And our founder and CEO, Eric Jones, was actually one of the original authors of SciPy. And so we also sponsor the SciPy conference every year in Austin, Texas. Yeah, so in college, so I originally studied computer science, but my program, it was very focused on Java. And I found I really didn't enjoy that. And I wasn't motivated. Computer science for its own sake was not super interesting. And so I dropped out and then was working various jobs for a few years trying to figure out what I wanted to do. And so I eventually found the discipline of biosystems engineering. And so I got my bachelor's from Texas A&M's Biological and Agricultural Engineering Department. And so biosystems engineering sort of draws from what I call the big four engineering disciplines of civil, mechanical, chemical, and electrical. And so it kind of takes whatever it can get to solve problems that are often very difficult. And so I like to compare it to sort of like a multi-class in Dungeons and Dragons, where maybe you take a few levels of fighter and a few levels of wizard and maybe a few levels of rogue to sort of balance yourself out. So it's sort of a specialized generalist discipline. I
kind of get it. So it's more like using the engineering method to solve general problems that are linked between those fields. So that's interesting, having a systematic approach there. And how did you get involved in the FreeCAD project?
So around 2012 or so, I was kind of in the decision of going back to school and trying to, at the same time, I was also switching to Linux full-time. And so I was looking for software that was in that sort of CAD area that was also following the free software philosophy.
In which year?
This was around 2012.
Okay, so not a lot back then.
Yeah, exactly. Yeah, and so I found FreeCAD around the time, but it was very difficult to use. There was, I could tell that the core was there, and there were some very interesting screenshots from some expert users as far as what was possible, but it was just too difficult to use as sort of a newbie. And so I was just kind of following the project, seeing how the development was going. And around 2015, I noticed that there was maybe a couple of releases since I first found it, and the usability, a few of the major pain points had been smoothed out. And so at that point, I was like, I think I'm ready. I want to try to get a pull request accepted in the project, and that way I'll kind of get my feet wet with it.
Okay. Did you have any experience prior with other 3D CAD applications before working on FreeCAD?
Yeah, so I had, not exactly for 3D CAD, but I did take an engineering graphics course, and that covered 2D CAD, and specifically we use AutoCAD.
Okay, you only used 2D CADs before, so no experience with other 3D CAD such as Autodesk Inventor, CATIA, or any other of the bigs?
No, it's kind of an interesting question, and when it comes to sort of these commercial software and the FLOSS alternatives, you have this potential for someone saying, oh, well, you've copied this commercial software. And so I'm actually kind of lucky, working on FreeCAD, and that I haven't actually used any of those other 3D CADs. Mm-hmm. And so I'm sort of immune from any potential litigation in that regard, ideally at least.
Yeah, in the similar way as the guys from React OS.
Oh, yeah, that's the sort of a Windows type implementation, isn't it?
Yeah, exactly. They need to do clean room re-implementation to avoid any lawsuits or any problem. So yeah, okay, that's good. So you come from a clean slate.
Exactly.
What would be your 1-minute elevator pitch for FreeCAD?
So FreeCAD is really interesting because it has this potential to sort of have an integrated design, engineering, and manufacturing suite. And so right now, for example, you can do the part design workbench, and you can make this parametric part, and then you can switch over to the finite element modeling workbench, and you can go in and set some constraints and sort of see how this geometry will behave under your engineering constraints. And then if, let's say, that geometry is okay or that model is okay, then you can go into the path workbench and you can generate G code to actually manufacture that part using something like a plasma cutter or a CNC mill. And so there's this really interesting integrated opportunity there. And besides that, FreeCAD also is sort of unique because the leading CAD options, they're all either super expensive, in the order of like $10,000, or they're free with a really big asterisk next to it. And you kind of have to check the fine print as far as what that means exactly. And so FreeCAD sort of offers the shared ownership model of free software. And so potentially the total cost of ownership of this software can, go down to zero or even negative.
Okay. What is the current general development status of FreeCAD?
The current general development status of FreeCAD, it is officially a beta. And so, the version number leads with a 0. And so you can kind of see that. What that really means, though, is that, we definitely have a commitment to making sure that if you have a file that works in one version of FreeCAD, say a recent version of FreeCAD, then it should continue to work. But some of the details, like let's say the actual Python API, or even let's say a macro, if you were to record a macro, that may need an adaptation. So we aren't being, completely seated up our pants in the development, especially because we are actually probably going to be out of beta status before too long.
Okay. By which version do you mean? Because right now I think you're at 0.18.
So yeah, the most recent release is version 0.18, and the development version right now is 0.19. Without getting too much into the roadmap, because I may get to that in a later question, I would say that probably after maybe version 20, 0.20 may actually be version 1.0. Really kind of jumping ahead, the main limitation from a 1.0 release for a lot of us is full assembly implementation. And I'd say we're fairly close to that, but it's pretty complicated.
Okay, so we'll come back to the assembly later on.
Yeah.
FreeCAD has a lot of building information modeling tools, BIM, which are kind of a special features of FreeCAD. Can you elaborate what are building information modeling software?
Yeah, so BIM, or building information modeling, it actually has its own workbench in FreeCAD now, but originally this was sort of an offshoot or an extension of the Arch workbench, which is sort of for architectural design. And the main developer of that, Jorg van Haver, he's actually an architect. And so he's sort of leading the charge in the project as far as the integration of BIM into FreeCAD. And BIM, mainly, we're using a Python library called IFC OpenShell. And so that allows us to manipulate what they call IFC, or industry foundation classes. And that's sort of just the interchange format for BIM. And so what that is it represents, they call like physical infrastructure data. Let's just say you have just a standard office building. You have sort of the HVAC system, the electrical systems, emergency control systems, security systems, and so forth. And so all of that physical infrastructure can be modeled in a combined way. And so especially in regards to things like HVAC, you can actually do building level analysis using the entire building representation digitally.
Okay, like kind of 2D analysis of airflow within your building to make sure that every room has proper airflow and all of that.
Exactly, or even potentially 3D. And you can also, there's actually a feature in FreeCAD, I believe, called the Arch site. And so with that, you can actually have like a solar diagram for a particular location integrated with your model. And so then you can do measurements based on, let's say, the average heating from the sun, certain angles of the building, and actually have a sort of a object in your model that represents the sun moving. And so you can have that sort of heating behavior change with time.
Okay, so it's not just something about the material, but it is more about the general systems within the building as well, being represented like with the standard. Okay.
In your explanation of BIM, you mentioned the workbench, and you also mentioned there's an architecture workbench in FreeCAD. Could you explain to our audience what a workbench is in FreeCAD?
Yeah, that's definitely something I should mention. So FreeCAD, one of the main draws for it is that it has a very modular architecture, and it's based around the concept of a workbench, which is sort of a specific to an application. And so, for example, we have, as I mentioned, the finite element modeling workbench, and so that has the tools and the, let's say, create a new mesh type of buttons that you would use to interact with your existing model. And so These are often Python-based, but you can also have native C++ workbenches as well.
Okay. The development of each of these workbench, I suppose they're all independent from each other?
Yeah, so we have sort of core workbenches that are actually in the main FreeCAD Git repository. And then we also have a sort of third-party workbenches. And of those, we have sort of the more popular ones, which have been added to. We have an add-on manager in FreeCAD. And so you can actually install that directly from within the program. And so that just clones, usually it just clones a Git repository into the correct location and adds that functionality.
What are the basic workbench that are already in the FreeCAD?
So yeah, with the workbenches, there's quite a few, but there are sort of basic ones or lower level ones, and then there are higher level ones, which are maybe composites or extensions of the lower level ones. And so some of the lower level ones are, for example, part, which just has very basic geometry and Boolean operations and so forth. And then you also have draft, which is a little bit more advanced, uses part, and so, but it's mostly oriented for 2D design, and it's very similar to AutoCAD. Then you also have Sketcher, which is a parametric 2D operations to be used for the part design workbench. So these are also sort of higher level ones. And then you have the very highest level ones, sort of design or specific workflow, such as the finite element modeling workbench or the path workbench.
Okay. And I suppose in the drafting workbench, you probably can import a part and then project to get a 2D representation of a part, and then add dimensions and tolerances on a drawing so that you can print out an engineering draft of your part. So
in draft, you can do that sort of thing. It's fairly freeform, so you can have text inside of the model and so forth. But if you actually are wanting technical drawings, there's a tech draw workbench that's specifically designed for that. And it's very interesting because you actually can create your model, your 3D model, and then you can have various representations of that embedded inside of your technical drawing. And you can also add dimensions like you mentioned.
Okay, and these are all linked back to the initial parts, like in the commercial CAD applications.
Exactly. And so you have, usually when you're, depending upon the sorts of changes you're making, you may want to have automatic recompute of the technical drawing turned on. But, you can also have performance concerns if you're making lots of changes, recomputing everything, the entire model tree every single time you make any sort of change. Can be very expensive. Or
if you're making major topological differences between your parts where this distance doesn't exist anymore because one of the leading edge or the dimensions but attached could disappear with your modification of the part.
Yeah, exactly. Like you mentioned, if you have instability in your model where, let's say, there are two solutions that are very close in when you're trying to solve for the big matrix that is your model representation, and you can have that instability. And so another instance of it is just in sort of a more mundane case where if you are going in and let's say you're in the input for the height of a cube or something like that, if you're just pressing the up arrow, every time that calculation has to happen very quickly over and over. So you're going to have bad performance if you have redraw turned on every time.
Okay. Previously, we spoke about the finite element modeling workbench. What kind of finite element libraries are integrated?
So it's a pretty big topic because, with FreeCAD, we just have Python. And so it's specialized as sort of a glue language. And so the potential is really, really big, but sort of the user-friendly potential is a little smaller at the moment. So I guess there's the two sides. There's the meshers and solvers, and then also post-processing options. And so for meshers, the most well-integrated we have is Gmesh. And then we're also, we have less well-integrated functionality with NetGen. And then as far as the solver, the best integrated one we have is Calculix. And that's mainly for, I'd say, thermomechanical analysis, mostly structural. But the nice part about Calculix is that it's sort of the abacus format. And so that's sort of a more popular, more mainstream finite element format. And so with the Calculix integration working so well, for example, if you had abacus, it should basically work just as a plug and play or a drop-in integration.
Okay. Can you feed back like the results from the simulation back into the part model and to optimize the geometry automatically, or you need to change your geometry manually based on the results you get from the simulation?
One thing I forgot to mention also for the last question rather, we also have a third-party CFD workbench that uses OpenFoam.
Oh, okay.
And so that's in development right now. And if you're interested in that, you can check it out on the forum. And so to get to the question that you just asked, so it's possible, but in certain situations, it's a little easier than others. And so you can use, let's say, when you are creating your constraints, you can use a parametric design. And so you can link something into a spreadsheet inside the spreadsheet workbench. But as far as hooking that all up, the machinery to do that is fairly manual right now. Although there's an effort by Micro Ellie on the forums. He's using something called PyFlow, and so that's sort of a graphical design as far as constraints. I haven't used LabVIEW, but I think that in terms of the approach, it may be somewhat similar, where you have sort of a drag and drop interface for various parts of your model. And so you can sort of have the flow back of the results of your calculation in an easier way.
Okay. So does FreeCAD support multiphysics simulations?
So it does, but it's a sort of at the level where you would really need to be probably a programmer to be able to do it, because it's fairly manual. So yes, but not in a very ergonomic way.
Okay, which way would a user need to do? Like, would it need like Python coding to create the model and to use some features and to talk directly to Calculix, or how would a user approach that kind of problem?
Yeah, so if someone was interested in doing multiphysics simulations in FreeCAD, you would want to probably dig into the FEM workbench. And in there, for example, you have a part where it takes what's in the model and then it spits out a file that it sends to Calculix. And so you would need to have additional Python code in, let's say, a custom workbench, and that would have to hook into that, so that maybe you would modify the file, or you would have the input for that file be the result of another simulation. And so you would have to basically become a developer for the FEM workbench, or have a developer level familiarity with it.
Yeah, or you might as well go with other tools that already do multiphysics by themselves at that point.
Yeah, and so, for example, in that regard, I think Salome may be available to do that. That's a sort of a related project that also uses OpenCascade, the same geometry and topology kernel as FreeCAD.
Yeah, or Elmer, I think, as well, can do multiphysics.
Yeah, and so FreeCAD also has Elmer integration, but it's probably the least established of the ones. And so I believe it was maybe a Google Summer of Code project, but there hasn't been much, there sort of hasn't been someone else to pick up the banner and continue that project.
So we talked about the drafting earlier to generate 2D drawings. You talked about model update. Is it auto-updating, or is it like a button you need to click on to re-update the drawings when the geometry are changed? Or is it a manual operation to regenerate the drawing?
So I think that this may have changed recently, because I believe in the past it was always automatic. And so now I believe it's there may be a preference that was added. And so it's possible to have it automatically update. Okay. But there's performance concerns. And so you can also just do it manually, where inside of the model tree, there'll be a little indicator to show that something has changed. And so then there's several ways to sort of force a calculation, and you can just do that whenever you actually want to see the results of what you've changed.
Okay. What kind of annotation can you have on the drawings? Could you have like probably normal tolerance plus or minus a dimension, but can you also have geometric tolerances? So
in TechDraw, I believe the annotations do support that, but there's actually a specialized GD&T, so geometric dimensioning and tolerancing workbench that's not integrated into FreeCAD's core, but it is available through the add-on manager. And so that's sort of more specific to that purpose. Okay. I wasn't aware of that. Yeah, it's pretty interesting. It's actually fairly well done. I think it was someone's master's thesis. They posted about it on the forum. Okay. Is it still under development? So I don't believe it's under active development right now. Okay. How does FreeCAD compare to other
2D drawing software like LibreCAD or QCAD?
Yeah, people often come into the forums and ask us this sort of question, and we don't really hesitate to recommend LibreCAD if someone's really specific to a 2D drawing environment and they don't really need the 3D drawing. And one of the reasons for that is that, besides that FreeCAD is 3D first, we actually have one of the areas of ongoing development is the fact that when you're doing 2D drawing, you have a lot of individual objects rather than, an object with several geometric components. And so we have sort of performance concerns. And so there's sort of a central object in FreeCAD. One of the central objects is called the document object. And so every point, every line, when you have these very, very large drawings, is its own object in the tree. And so it's too heavyweight. There's an ongoing development by a guy who's a transportation engineer in Illinois. His work often involves fairly complicated 2D drawings of, let's say, highways and so forth. And so he's very interested in getting better performance for the sort of 2D area. But right now, I would say if that's your main focus, 2D, you should probably try LibreCAD.
There are many commercial parametric 3D CAD applications, such as CATIA and SolidWorks from Dassault Systems, Inventor from Autodesk, Solid Edge, Pro Engineer, Siemens NX. Is there any way for FreeCAD to open files from any of these competitors in question marks?
Yeah, so I would say that your best option is probably going to be step files, and that's just because those retain some information about your model in a better way than what's probably the most common interchange, which is STL files. And so if you actually want, let's say, a high fidelity model with perhaps the colors and so forth of your original model preserved, then the step file is your best bet. But unfortunately, on the internet, a lot of what you find are STLs. And with those, you'll have problems because it's a triangulation.
I'm feeling your pain with this.
Yeah,
exactly. Like just doing assembly in normal in other CAD software that support assembly, just selecting a facet, or like it's almost impossible to use these models, the STL models.
Oh yeah. Yeah, absolutely. So one of the main problems that people have when they have these STL models is that they'll go in and they'll want to do something with it, like let's say a Boolean operation. And so they'll want to get the difference, and then they'll end up slicing a hole in their model, and it no longer is manifold. And so it's not watertight, in other words. And so it'll have an inside that, doesn't have an outside.
The inside communicates with the outside. There's no proper boundary between the inside and the outside.
Yeah, exactly. Yeah. And so, a lot of times you'll have various graphical glitches where, the lighting for the inside face, it doesn't calculate correctly. And so the model will appear to be black. And so that's a fairly common problem people see working with these STL files.
Okay, but is the step format a standardized OpenCAD file format? So I could export one model with, for example, CATIA, and can I import this model in FreeCAD or vice versa, or is it not working at all?
Yes, so that does work. It's just that there may be, let's say, particulars. I haven't heard of any major issues, but there may be some, let's say if there's something proprietary in your original model, it may not make it into the step file. But if you do find any issues, be interested to hear about them. We could file a bug and try to fix them.
Yeah, I've used the step conversion a few years ago. There was Urban Tabby, a small vehicle that I had access to the step file. It took quite some time to open it up. I think it was in FreeCAD 0.15 or 0.16. I don't remember which version it was back then, but or maybe even 0.14. But yeah, I opened it up. I could look it up. I could turn it around. I didn't change the model, but it opened it well. It just took time to convert it from the step file to the original FreeCAD format in there.
Yeah, and actually, it's interesting that you mentioned that, because there was a development, I think, around the 0.16 release where I think the feature may still be experimental, but there's an option to use vertex buffer objects. And so when you have very complicated step files, for example, I had one that was of a server, of a rack server. And so you open that and it'll take you several minutes to open, but with this experimental VBO functionality, it dropped down, I think, an order of like 20 or something like that. And so there was a very big speed up, but there was a couple of bugs that were associated with it. And so it's not quite mainline.
Okay. What is the FreeCAD's native file format?
So FreeCAD uses .fcstd files or FreeCAD standard, but that's really just a zip file. And so if you have one, you can just run unzip on it, or even if you're on Windows, just rename the extension, and then you can unzip it and look and see what's inside of the file. And if you were to do that, you would see there's a couple XML manifests, and those manifests describe the other files inside of that archive. And so, for example, you might have an object that represents a certain lighting property of your model, or you might have the actual raw the actual boundary representation of the file, or other various things that can be imported into the model.
Okay, would it be possible to use a versioning system to alter, like to keep version of files by reading those values? Like in Git or any code versioning system, you have access to the raw code, so you can do difference and compare versions. With a binary file format with the usual CAD system, you cannot do such. But the fact that the data is hidden within zip, is it still possible to compare and to do versioning with the FreeCAD files?
Well, so it's possible to do versioning, but the comparison is not so useful. It's kind of similar to Jupyter notebooks. If you've ever tried to look at the diffs in those in Git, the actual diff is mostly garbage because it's got all the other stuff in there. And so you can do that, but it doesn't really represent the diff isn't really semantic in that way. But there is ongoing development to do that. I think it's more than one front, because there's quite a bit of interest in being able to do that. And I think the approach that's probably going to end up working is actually a special way to serialize the file into something that makes sense to version and Git. So basically it would be something that you could use to recreate the FreeCAD file, but it may not be the FreeCAD file itself.
Okay.
So what other file formats can be imported or exported by FreeCAD?
So it's a huge list. I would say some of the important ones that people would be interested in, there is the DXF support. Besides that, there's also DWG support, but it's sort of a complicated topic because
the licensing issues around the DWG, that was GPL3, and like FreeCAD was GPL2 back then, so you had to...
Yeah.
I don't remember the exact details, but I've seen stuff around that.
Yeah, exactly. I just remember a couple years ago reading some article about, the licensing confusion, just because I think FreeCAD may have even been removed from Debian at some point because of it, temporarily at least. Yeah, it uses DWG for those files. Yeah, so the list, I'm looking at the list right now, and it's pretty extensive. I guess a couple other ones that might be interesting to mention are VRML, and so that has some applications in robotics. And then BREP is sort of...
BREP, yeah.
Yeah, so that's sort of the native format for FreeCAD, at least as far as Open Cascade is concerned. And so that's a nice format because it represents everything in terms of the limits. And so rather than actually defining a surface in a particular location, it says that, defines it in terms of the calculus limits. And so basically that can be as precise as you need it to be.
Mm-hmm. Based on equation.
Yeah, exactly. Yeah, and so it also can work with G-code. So the path workbench, where sort of the G-code-like functionality is, it doesn't actually spit out G-code directly, but it can export it. And then also we have interchange with OpenSCAD, which is a fairly popular alternative floss CAD program. People like it because it's sort of programmatic, and so I think they call it the programmer's CAD. And so you can directly import the file, but you can also just use the OpenSCAD workbench, which just calls out to the program, and you can continue working directly in FreeCAD.
There's a Python interface to extend the functionality of FreeCAD. Can you elaborate on the integration of Python within FreeCAD and how it can be used? Because from what I've heard in the past, some functionalities were present within FreeCAD but not accessible through the graphical user interface. User had to use some Python commands to access some features. how much Python is integrated within FreeCAD?
Yeah, so when you open FreeCAD, one of the first things you may notice is depending upon your settings, there should be a Python interpreter right inside the program. It's interesting because when you click a button on the interface, there's actually a Python command being executed. And so one thing you can do is use the macro system in FreeCAD. There's a little record button. And so you can go ahead and perform some operations after clicking record, and then go in and look at the actual Python that was executed by the program. And so for the most part, we try to expose the Python that has been written, but there may be something that you want to do that we haven't thought of yet. And so that's a really good way to get some inspection or some introspection into what the program is doing and what you can do with the Python as well.
Okay. And is there still a lot of features that are not available in the graphical user interface, but are available with Python code?
I wouldn't say not necessarily in Python code, but I would say there may be some things you may have to go a level lower into the C++ to do some things. But, I guess if you wanted to, you can. It's very transparent as far as the functionality.
Okay. We briefly talked about it earlier, but one of the main features that is not yet finished for FreeCAD is an assembly module. That is actually one of the things that prevents me from using it much more than what it should be used. There have been many attempts in the past to tackle this specific problems. If you look up the forum right now, there is assembly 2, assembly 2 plus, assembly 3, assembly 4, many different attempts at making this specific modules. What is the current state of assemblies in FreeCAD officially?
Yeah, officially. Yeah, like you mentioned, there's several, I guess, more or less competing unofficial approaches. And then there's the actual assembly workbench, which is in the code, but it's turned off by default just because it doesn't really behave very well. And that was sort of the first attempt at the assembly functionality. And so for a long time, it was something that sort of lay dormant in terms of development because it's really pretty difficult. And it wasn't until fairly recently that a new developer started contributing to FreeCAD by the name of Real Thunder. So Real Thunder got started, and he's really prolific in terms of the amount of code that he produces, but it's a little difficult for a project like FreeCAD in that we only have maybe one very serious C++ reviewer. And so he's very quickly outpaced the ability of this new potentially disruptive code to get merged into master. And so there was sort of a diversion or divergence of functionality for a while. And so just recently we had a very big pull request that got merged, about 70,000 lines of C++ code. And this is sort of very low-level FreeCAD, changing the behavior, that's sort of clearing the path that's going to be required to implement assembly in mainline. I would say probably one of the most mature assembly implementations is going to be the assembly 3 workbench. And for a long time, that actually required running a Real Thunder's fork of FreeCAD because the enabling functionality wasn't in the mainline code. And so with this big pull request merge, it's now possible to do that, to run assembly 3 with mainline FreeCAD. And so the next step is to get assembly 3 itself ported into FreeCAD, although what will probably end up happening is something not quite assembly 3, but maybe drawing with some of the other functionality of the other assembly implementations to finally get merged.
Okay. What were the blockers that caused all these problems?
So it's really, I would say, one main problem, and it's called topological naming problem. And so it's a little difficult to explain verbally, but let's say you have a cube and you want to refer to a particular face on the cube. You have to come up with some numbering scheme to refer to that. And so, maybe you would start on the bottom, that'd be face 1, and then you would go around the sides and end up on the top. And so in this case, it's not too complicated. But if you have something attached to that cube on, let's say, face 1, and then you have another operation which changes the number of faces, you have to make sure that those faces are renumbered in a way that doesn't break the existing relationships. And so it's a very tricky problem. And that was basically the main stumbling block to get this working.
Okay, to maintain a stable numbering for the topologies of the parts, and so that assembly can work reliably with part modifications and reassembly each time you open up the file.
Exactly. You need a stable way to refer to geometric or topological entities so that one thing can depend on another thing. And you have to make it robust to changes so that, for example, if you have a groove in a face of a cube and that groove, you extend it all the way down, you end up splitting that face and you have all these new extra faces. You have to make sure that, let's say, something attached to that face is in the right spot in the end. So if you try to change a parameter in the beginning of your model, the rest of the model can recompute correctly.
Okay. For those looking at the forums, you will be able to see many examples of assembly being presented without even an official workbench. What is the workaround that those users are using to make it possible to have assemblies in those screenshots? Yeah,
so one of the very prolific posters in the forums, I'm not sure to pronounce the name, but PPEWMAM or something like that. Yeah, he uses a fairly manual approach where he just goes in and edits the placement of individual parts. And so he'll have sort of a master sketch with all the different pieces, and then he'll go in and make the various pieces and then place them manually. And so for someone who, I guess, has a quick workflow for doing that, that's okay. But the problem, I guess, that works for his workflow where a lot of times he's making, let's say, adapting an existing model, like let's say a technical drawing and turning that into a FreeCAD model. That's something like that will be fairly static, but it doesn't really work for a parametric assembly.
Okay, something that moves a lot, like you cannot recalculate the position of each parts easily.
Yeah.
Like mechanical linkage and all of that.
Yeah, exactly.
So assembly is kind of the big blocker for the post-beta status of FreeCAD. Do you think in like 0.19 is currently in development? So in like kind of 2 version, you think you're going to have this situation at least partially solved?
Yeah, I think so. So right now we're very close to a feature freeze for 0.19. And so in the next year, I would say that assembly functionality, the impediments have been cleared away to getting that working. And so it's really just a matter of, right now we're sort of still dealing with a few bugs from the big merge, as we call it. And so once we've kind of wrapped those up and released something that's stable, we can go into actually getting the assembly functionality mainlined. And so with that, we're going to ideally bump to 1.0.
Okay, if users want to test it out, they should run the dailies of 0.19, the current development dailies, and then use the assembly tree workbench, I suppose?
Yeah, so you can go to GitHub, go to the GitHub repository for FreeCAD, and in the releases page, we have some, as you mentioned, the current development dailies, and then you can just go into the add-on manager and install Assembly 3 directly, and then from there, once you just restart FreeCAD, then you'll be able to go.
Okay, so that's the easiest way to test the solution as of now.
Yes, and it's nice because previously, like I mentioned, you had to actually run Real Thunder's forked version of FreeCAD, and so that often meant compiling it yourself.
Yeah, I think, and under Ubuntu, I think there's a daily PPA, and probably there might be under Fedora. I don't know if there's a Copper repo for that, or is there?
There previously was a Copper repo in Fedora, but I'm not sure what the maintenance status of that is. As far as the Ubuntu PPA, though, I maintain the stable and the daily releases for that, so I can definitely say that they're A+ quality. But if you have any bugs, let me know.
Okay, so which software license is used for the FreeCAD project, and is there any reason for this choice of license?
FreeCAD uses LGPL version 2 or later. And so the main reason that we use that is that's the license of OpenCascade. And so because it's sort of the core of our application, we ultimately are going to use the same license. Although there is a little bit more to it. There's actually a post by one of the founders of FreeCAD, Jürgen Riegel, where he talks about it. And the idea was that he felt that LGPL would make FreeCAD a little bit more amenable to commercial adaptation. And so that was what he went with.
Okay.
Are you aware of any company using FreeCAD instead of a commercial alternative?
So the Lulzbot 3D printer, which is made by Aleph Objects, I know that they were using FreeCAD in the past, and I'm not sure what their current status is because I just heard that they had a fairly large layoffs recently. But other than them, I'm not sure of any other companies that may be using it. They may just not be letting us know.
Okay. And what about universities?
As far as universities, I know that there are quite a few that use FreeCAD in their courses. And a lot of times we notice that just from major spikes and people visiting the forums. I'm not sure of any in particular, but I know that in general, we participate in Google Summer of Code. And so that's a really great way for potential FreeCAD developers or people interested in FreeCAD who are going to college or university to get paid to contribute to FreeCAD. And so, yeah, that's a very interesting potential with universities and FreeCAD.
Okay. Are there any scientific articles citing FreeCAD, or how would it be possible to cite FreeCAD in a paper?
So I just fairly recently went on Google Scholar and just checked this. And so there is actually one that did a study on optics. I didn't really dig deeper into it, but so I know that they do exist at least. And as far as citing FreeCAD, it's interesting because there's an organization that kind of just I recently found out about called JOSS, which is the Journal for Open Source Science, I believe.
Journal of Open Source Software.
Yeah, that's what it was. Yeah, JOSS, Journal of Open Source Software. And so I think I was interested. I'm not sure exactly if FreeCAD is quite right for what they are doing, at least as far as, I'm sort of coming in 17 years after, FreeCAD was originally released today. So I don't know if I'd really be the right one to, submit a paper for FreeCAD. But I think if something was in that journal, then that would be something that could be cited.
Yeah. And so I kind of a push that could be done for FreeCAD in scientific application is like because traditionally it's not a traditional scientific software by itself. It's more like engineering software for designing parts and doing assemblies. But eventually, like for designing scientific apparatus, that could be interesting to use FreeCAD as a standard so that the model could be shared among research teams.
Absolutely. So I know, for example, there's an open hardware project using FreeCAD, I believe, that I think they're working on a camera. And so something like that, could be very easily adapted, or rather, you could, those same sort of principles, you could go and make sort of an open source microscope. And so CERN recently announced sort of a push for open hardware. And so, yeah, there's definitely some interesting possibilities there as far as applications of FreeCAD for designing scientific equipment.
Yeah. Talking about the community or possible community, currently the FreeCAD community, how many people are currently involved in the project, roughly?
It's hard to say. So I would say there's maybe on the order of 5 super active developers. And then there's a long tail of maybe 20 or so less active, moderately active developers. And then there's a very large number of people beyond that who, let's say, help out in the forums or do sort of FreeCAD evangelism and so forth. Okay.
And what are the main communications channels within the project?
So the forum is where everything happens, although we do also have a subreddit, reddit.com/r/FreeCAD. And then we also have a Twitter account, FreeCAD News, that has some announcements as well. But I would say definitely the main venue for communication is in the forum.
Okay, but is it the same communication channels for developer and for support requests and general discussions, or do you have a mailing list for developers or for pull requests or those things?
Yeah, so it's there's separate sections. So we have, I guess, sub forums. We have sort of the user section, the developer section, and then we have sort of a third section for every other language besides English, so that the international community can help each other out in their native languages.
Okay.
So is the project actively looking for contributors, or are you searching for specific contributors like documentation writing or translating, or can people contribute without having knowledge of Python or C++ programming?
Absolutely. So one thing with FreeCAD is that it has the difficulty of not being super user-friendly. And so anyone can come in basically and try to document, let's say, when they open up the program, they were expecting something and maybe they tried to do something and instead of what they expected, something else happened. And so even, if you have no familiarity with CAD, you can go in and write about your experiences and and let people know. Let's say report bugs if you try to find something, and join the community. And so one of the big things is also just FreeCAD can do so much, but a lot of people don't know just how much it can do. And so also just going in and reading the forums and sharing things that you find interesting, even that would be a great help.
Okay, so if someone is going to GitHub and looks into the bugs, is there any bug labeled with an easy first-time bug to fix, or how easy is it to find a bug someone could work on?
Well, so I guess going to GitHub, you'll probably notice that I think the issues tab may be disabled. At least I think it should be. And although I would like to probably move to GitHub for bug tracking as well. We actually run our own run our bug tracker. And so it's on a separate website, freecadweb.org/tracker. And we do have, I think, a low-hanging fruit tag that you can go on there and actually see some of the bite-sized bugs that we have prepared.
Okay. And we'll switch to a slightly lighter topic. What is your vision about FLOSS and its importance for the openness of science?
I think it's absolutely vital. If you can't really reproduce it, then is it really science? So I think that it's only going to become more important. And if it isn't, then that's kind of not good for the healthiness of science in the future, to continue to rely on closed source tools and so forth.
Okay. And as an engineer, you really see it important to use FLOSS tools as much as possible.
Yeah. And so on the topic actually of FLOSS and engineering, one of the FreeCAD community members I mentioned, the transportation engineer in Illinois, but yeah, he has a talk specifically on why FLOSS is important for engineering. And it's really, if you don't control your tools, then you aren't really in control of your own profession, is sort of his argument.
Yeah, I saw that. I saw his presentation as well.
Oh, you did?
Yeah, I saw. I was getting you there.
That's great.
And do you think FLOSS can have negative impact on science?
Well, I guess it's a good thing to consider potential negative impacts, but I guess I can't really think of any at the moment. There's sort of the prestige element of brand name software, but I don't think that the continuation of that is super great.
Okay, we are almost done with the interview, and we will proceed with some of our classic quick questions. In recent years, what do you think was the most notable scientific discovery?
I guess maybe my Python fanboy showing, but I think the imaging of a black hole with Python is absolutely incredible. Besides the fact that imaging of a black hole is something I would have never considered possible as a child. But, the fact that it was done in Python, I think is a great indicator of the validity of Python's scientific ecosystem. Okay.
One question we asked all our interviewees is, what is your favorite text processing tool?
I use NeoVim.
Okay.
But if you use Nano, that's good too. Whatever gets the job done.
Nano Power User Unite.
Yeah, exactly. I always have to run update alternate to change my default editor because on Ubuntu it's Nano, and I have to switch that around.
Is there a topic in science about which you recently changed your mind about?
No, and so I guess I saw this question. I was like, I probably should, right? But I guess if I saw some evidence, I would love to change my mind about something in science.
Is there anything else we forgot to ask you about and that we should have known to ask you about, or anything else you would like to share with us?
Yeah, so at FOSDEM 2020, there's going to be a FreeCAD presentation on Saturday at, I want to say, 11:30 a.m. And so Yorick, myself, and Sliptonic, who is one of the main developers of the Path workbench, are going to be presenting talking about the FreeCAD ecosystem. And so if anyone's attending, feel free to come say hi. We're going to be there all weekend, and we may even have a FreeCAD specific space at FOSDEM.
Nice. It will be a joint talk between the three of you?
Exactly.
Okay. How long will be the talk?
It's a half-hour talk.
Okay. Well, there's a lot of things that could be said in half an hour.
Exactly.
Okay.
Yeah, that's the open source design ecosystems around FreeCAD is the specific title.
Okay. So some of our listeners will probably look this up. Thank you, Kurt, for your time in this interview. For our listeners, what is the best way to contact you?
So you can find me on Twitter at thekurtwk, and I blog at kwk.systems/blog.
Okay, thank you.
Thank you. This will be all for today's episode of the Floss for Science podcast. I hope you enjoyed the interview. You can reach me on Twitter at DLPK.
And you can reach me at _dbrass or both of us at Floss for Science. Also, we are on iTunes, Stitcher, Google Play Music, and Spotify. You can help us by recommending our show to your friends and colleagues.
Our current schedule is to release an episode on the first Wednesday of every month.
Our website is located at flossforscience.com.
where you can find all of our contact informations and a link to our GitHub page where you can submit subject ideas for future episodes. You can also listen to our episodes or find the RSS feed to get all of our interviews delivered directly to your favorite podcast player. We hope you enjoyed the show and that we will see you all in your next episode. Bye.
Bye.